Right, this is second part of the 10-1 explanation. So what you have to do is you have to come up with the equation here, and this is the we have to look at. So we do that uh, Z statistics, right? So standardized test statistics. So because we got the Z score, so the statistics minus parameter. First of all, what's the difference from those two, right? That's the statistics. Okay, so statistics uh, is is 0.6 minus this one 0.6 minus 0.44, which is 0.16. Okay. Some of you often ask me what is parameter for when we state null hypothesis for two samples, right? Uh, that is two proportion is this is 0. So I know it's the same it kind of same thing, but first I will put this one the statistics equal fraction 0.16 minus 0 because that's the parameters. Now, denominator has to be standard error of this. So how do you get standard error? The success failure divided by 50, success failure. You have to multiply the numerator, divide by 50. So that's the equation. So let's write down. I think you have to have a square root sign. Success 0.6 times times 0.4 divided by 50. Adding, you have to add, right? Because it's a difference, you have to add the standard deviation, standard error. The same thing, 0. Sorry, 44 times 0.56 divided by 50. Okay. So this is the statistics, and from the Z statistics we get the alpha. Okay, alpha. I'm sorry, a p-value. So let's plug in this. I do one by one. Maybe I get standard error first. Okay, so square root. Guys should parentheses, two parentheses, 0.6 times 0.4. Close the parenthesis because this is a numerator, and divide by 50. That's the first equation. So I will close the another bracket. Okay. Now I will add and another double brackets 0.44 times 0.56, close the bracket and divide by 50 and double bracket on single bracket to close this, right? So that's the standard error. So let me see, write down standard error. So this is 0.098. So I don't know how much I should carry, so maybe I should put this tilde fraction 0.16 over 0.0986. That would be, oh, right, I'm supposed to tell you 0.0986. Yeah. All right, so this is, let's type in. So yeah, 0.16 divided by 0.0896. I'm using calculator, by the way, so it's going to be 1.6. Let me get this one, 1.623. Okay, so let me, it's going to be 1.623 positive, right? That's the z-score. Okay, z statistics, I mean. So let's run the z statistics, and it's one tail, right? The hypothesis is one tail greater than tail, so that's one side. Okay, so again, calculator, you go to stats, I'm sorry, second bars. We have to check the normal CDF, right? Normal CDF. So you get normal CDF. The tail is this number, 1.623. Upper 1.99. Okay. Mu is 0 and standard deviation is 1. That's the standardized, right? Okay, so this is 0.052. Ooh, this is really cut. So this comes on 0.052. Oh, not here. The p-value is calculated 0.052. It's just the edge, actually, 0.052. But it's more than 0.05. So it's failed to reject no hypothesis. Okay. Um, yeah, it's fair. Okay, so it's a fail to reject no hypothesis. So it's, let's see, let me kind of put. So the no hypothesis, it's not. There is not significant evidence evidence that instructor studying with instructor A, students who are studying or who study with instructor A, there is no significant evidence that students who are studying with instructor A have better passing rate. Okay, so this is the whole process. Okay, second question is kind of important, and I might ask you this. Describe type 1 error, type 2 error in this setting. Which error could you have made in part A? Okay, so I will create the, I think I create the, uh, let me share this one. I create the flashcard when during the when we study this one. chapter 9. So if no hypothesis true, but we reject no hypothesis. Did we reject no hypothesis? No, right? So we we fail to reject no hypothesis, right? Let me look at the comment. Okay. So we fail to reject no hypothesis, right? So the scenario is the other one. So when alternative parameters are valued true, name the probability test which reject no hypothesis. That's so. This is I'm sorry, not this is about. Listen, when alternative hypothesis is true, we fail to reject them. So that this is the scenario we have right now. So it's called type 2 error. Okay, which means instructor A it's for us. Instructor A is kind of when we look at this. Oh yeah, instructor A is studying with instructor A is better result for the students. However, there, for hypothesis test, there is not significant evidence that the students who are passing with instructor A have better passing rate, right? So from the when we compare the p-value. So in that case, even though instructor studying with instructor A has better passing rate, the we accidentally uh, uh, failed to reject no hypothesis. Okay, we couldn't sort of honor the alternative hypothesis. So that's type 2 error. Okay, that's this. Okay, type 1 error on the other hand, what if this number is low, right? If it's 0 0.003 low, it's going to be 0 0.49. What if this is p-value is 0 0.049? So we reject null hypothesis, and you have to say there is significant evidence that students who are studying with instructor A have better passing rate. Okay, so that's how you have to answer. Now, but if this number is low, and if for sure that um, it wasn't that much different, or maybe it's instructor might be usually a better teacher, but for this sampling distribution didn't come out right. There's a case like that too, right? So that we call type 1 error, which is this. When no hypothesis is true, we reject no hypothesis. So that's type 1 error. Okay? Just remember this. And there's one more thing I want you to remember. It's this power of test. When alternative parameter value is true, name the probability test that we reject happens. That's it's called the power test, power of test. Okay. So at this moment we don't have any example of the power of test, but just remember type 1, type 2 error, and I will ask you about it. Okay, for upcoming tests. Okay. Have a nice day.